If we graph this equation by point plotting, we should be a little careful of our choices just to make our graph convenient. So we will do a table, and we're going to pick values to plug into the x, and then we'll solve for the y. Now, we would really like to make the fraction cancel. So if you can think of things to plug into x that would make this denominator cancel. How about a 2? If we put a 2 there into x and then plug it in, y equals negative half times 2 plus 2. When you work it out, your 2's will cancel on the diagonal to give you negative 1 plus 2, which will be 1. So 2, 1 makes this true. Any multiple of the denominator would work. So you could use a 4, a 6. You could also use the negative multiples, negative 2, negative 4. So anything that the denominator would divide into. Another really good choice for x would be 0. If you put 0, 0 times anything gives you 0. So negative 1/2 times the 0 will give us 0 here. 0 plus 2 will give us 2. So 0, 2 makes it true. And we just need one more point to graph this one. So let's just pick a 4 because 2 will go into 4. So y equals negative 1/2 times 4 plus 2. Your denominator will cancel. So it gives us a negative 2 plus 2, which is 0. Now we'll plot these ordered pairs. So first of all, 2, 1. We'll start at 0, 0. So move to 2 on the x and 1 on the y. Make your point. Go back to 0, 0. We're going to plot 0, 2. So don't go over. Go up 2. Make a point. And then we'll do 4, 0. So back to 0, 0. Over 4 and up 0. Now we have our points. And then we will connect the dots to draw our line. So our next one, if we want to graph y equals 3x plus 6, and we're going to do it by point plotting, we want to find things to make it true. So we'll make our chart. Right, and we're going to plug into x and then solve for the y. So always plug into the one that's not isolated. So if we let x be 1 and write it down, plug it in, y equals 3 times 1 plus 6. 3 times 1 is 3 plus 6 will give us 9. So this is getting pretty big. It makes it true, but it might be a little inconvenient. So let's plug in a negative 1 and see if we can get something smaller. So if we plug in a negative 1, so y equals 3 times negative 1, we're back on our original equation, plus 6. 3 times negative 1 is a negative 3, plus 6 is 3. So negative 1, 3 makes it true, and that's going to be a little easier to plot. And let's try another negative value. Let's say we have a negative 2. So y equals 3 times a negative 2 plus 6 will give us a negative 6 plus 6 will give us 0. And let's get one more point, just since the first one is going to be a little bit off my grid. What if we picked a 0 for x? So if we picked it, so we'd have y equals 3 times 0 plus 6. 3 times 0 is 0, plus 6 is 6. We didn't have to have 4, but that will just give us an extra one since one is a little bit off. Right, so 1, 9, if we try to plot it, here is our 1, and this just goes up to 5 on my grid. 6, 7, 8, 9. So it's going to be about right here. Okay. Negative 1, 3. So go back to 0, 0. Do negative 1 on the x and 3 on the y. 1, 2, 3. Right. Negative 2, 0. So back to 0, 0. Negative 2 on the x, 0 on the y. And you can see those do line up. I'm going to go ahead and get my 1 more points just so I can make a little better picture. So it says 0 on the x. Don't go across, but go up 6. 1, 2, 3, 4, 5, 6, which is even a little bit off. But notice all 4 points line up nicely. We'll connect the dots. And this gives our line.